Hi guys, in this video I want to talk to you about energy. What is it and the different types? First question, what is energy? Really, honestly, it's a pretty abstract question to think what is energy exactly. So for now, I want to just offer to you what it is not. It is not something that you can just hold like a battery. Um, it's something more tangible and abstract than that. It's not like some fluid or particle or thing that you can just hold. It's a it's an idea. It's a very useful idea. It's an idea that seems to work in so many different contexts. But it's not something physical that you can hold. Is the key idea. Um, when we talk about it in physics, when you're talking about it in the real world, it's a bit more abstract. We'll leave that there. So, what is energy? We're going to keep that sort of open-ended for now, and hopefully you'll have a better intuition for how it works when we go further into how it works. Okay, so the different types of energy. Let's pause. This is the demo tape. Okay, so something you probably heard from middle school science is the classic form of energy is energy in motion. So we call that kinetic energy. I'll write the symbol. I'll write the symbols later. Kinetic energy, energy in motion. That's like the standard thing. So right there, you have one form of energy when it's in motion, but notice that it stops at the peak. It has zero motion. It's at rest for a moment. So it's slowing down. The motion is decreasing. Is the energy decreasing? No, it's just changing forms. It's just going somewhere else. So it starts in energy of motion, and then where does it go? The other classic one you probably heard of is it's gravitational. There's energy stored in the position of this object because there's a gravitational field pulling it down. So that is gravitational energy. Those are the kind of standard ones. And you can think of other forms of energy if you can think, how can I get something moving? There is some energy transfer taking place if you're getting something to move. Okay, so what demos do I have for you? Let's see. To start off with, I guess the most important one in terms of regions physics are gravitational potential. There's also energy stored in elastic objects. So if I had like a rock or something on the edge of this, like a slingshot, and I released it, I could send that rock flying at you. So that would be transferring energy from the stretched position of this rubber band or whatever object to some other object. The energy in this is called spring potential energy. Elastic potential energy kind of means the same thing. Those are the three big types of energy that we deal with in regions physics. There's also one other energy that's less neat. Those three that I mentioned, kinetic, gravitational, and spring, have nice equations that go along with them. This other one is something that's really important in the real world, and sometimes we just like neglect it in physics. So, when I have a book, and when I slide it, at one point it's moving, and then it comes to rest. Oh my goodness. So it had energy of motion, it had kinetic energy. Where did that kinetic energy go? Can you think about it? So if you had some kind of infrared thermometer, you would see that the temperature of this board right here, it's slightly increased because the atoms of the book kind of rubbed against the atoms here, that frictional effect. And so the energy was sort of lost due to friction, but it was really just dissipated here. It went to the motion of the particles of the board or the surface. So that's kind of where the energy goes. Kinetic energy of like all these little atoms, on average, it's called like temperature. That's what we interpret as temperature. So the temperature of this increased, lost it as heat. That's one way to say it. The region's terminology is internal energy. So when you're seeing something come to rest because of friction, the energy analysis there is saying that the kinetic energy goes into internal energy. It's not destroyed, it's not lost, it's going to another form. Just like when I throw the ball, it's going from kinetic to gravitational. Another example of this is when I drop this, it starts at a certain height. It doesn't go up to that same initial height. So there's an energy difference there. I started with some amount of gravitational energy, and then it has a different amount of gravitational energy. The difference, where did that go? It went to sort of heat up here. When there's a collision, you're losing energy to heat. Okay, so those are the big ones. The other ones I wanted to show you, just important for you to know, just like generally to have some intuition for energy. There is, when you're hungry and you're eating, you are, increasing your own energy. So it's like, what form of energy is that? What do we call that? There's energy stored in the bonds of these of food, and your body breaks up those bonds and kind of stores it in a different form, ATP, and then breaks up the ATP to do stuff in your body. So chemical potential energy, that's like one broad term. Chemical potential energy is why, like, when you light up a fuel, add a little bit of energy to the fuel, that it will continuously change that chemical potential energy in the fuel to, let's say, heat. It can eject, let's say, gas molecules really quickly, like in the air, and that's kind of what's causing a car to move, so much of our combustion vehicles. Magnets. There is energy stored in the interaction between magnets, electrostatic interactions. That's also a thing. I'll say electrical energy stored in a battery, or that you get when you charge your phone. Those are harder to calculate, so that's why I don't really deal with them in Regents physics, but just important for you to know. Hope you enjoyed that. See you in the next video. Just kidding. I wanted to summarize. What is energy? I want to say the key ideas here is that it's something, it's essentially just a number. Something that is conserved. We'll talk more about this. Something that is conserved and has different ways. So we've seen conservation before with momentum. Momentum is essentially just a number that when you add up the momentum of objects in a system before and compare that to the momentum of the objects in the system after, if it's a closed system, overall it's the same. And energy is exactly like that. It's just this number. When you add up all the different types of energy in the beginning and compare it to all types of energy at some later point, if it's a closed system, then that number will be the same before and after. We say it's conserved. It can be stored in different ways, kinetic, gravitational, potential. So the key ones for Regents, Ke. This is kinetic energy. Energy of motion. This has an equation. You can see it on your reference table, but we'll talk about it more later. Potential energy. This is really just gravitational potential energy. Energy from position in a gravitational field. It's not just position that's important. If I were to turn off gravity and just like hold an object here and then drop it, I wouldn't be able to get kinetic energy out of it. It's the energy in the gravitational field and that other object, like the interaction between them, that gives rise to this, what we call potential energy. Gravitational potential energy, to be specific. And then the other two. This is spring potential energy, sometimes called elastic energy, stored in a spring or a trampoline type of thing. And then Q, internal energy. Energy stored as heat loss due to friction or a collision. So if two objects were to like collide and come to rest, their energy didn't just like disappear. The kinetic energy became something kinetic. Well, heat. You'd see the temperature change a small amount. So that would be internal energy. Also, like if an object is coming to rest and friction is slowing it down, we'd also call that internal energy. Okay, see you in the next video.